Okay, here we're looking at the problem where we've got weights of students' backpacks. They've told us it's normally distributed, so that's a key idea. They've given us the mean of 3.3 and a standard deviation of 0.3. So first thing we want to do is draw our distribution, put our mean and our standard deviation on that distribution. Then what we've got to think is, what is it they're asking us to do? They want us to calculate a probability, which means we need to turn this distribution into a z distribution. So z distribution, remember, has a mean of 0 and a standard deviation of 1, and our formula to turn it into from one to the other is z equals x minus mu over sigma. So that's taking an x distribution and turning it into the standard normal distribution. So let's have a look again. We want to find a probability that is between 3.3 kilos and 4 kilos. So on the graph, I've shaded in the area between the mean of 3.3 and the value of 4.0 kg. So remember, the bottom axis is just your number line, and think of your number line going from small to bigger. What we want to do now is we want to find the equivalent value on our z distribution using the formula. So our formula, let's use the numbers. Z equals x, which is 4, minus the mean of 3.3 over the standard deviation of 0.3, and that gives us a value of 2.333. If I have to draw that on my z distribution, you can see that it's above the mean, and the area that I've shaded on my z distribution is equivalent to the area on my x distribution. So therefore we can write down the probability that x is between 3.3 and 4 kilos is equal to the probability that z is between 0 and 2.33. And when we look that up on the table, that gives us a value of 0.4902.